Use the given graph of f to state the value of each quantity if it exists. All right, let's take a look at what's going on here. First, we have the limit as x approaches infinity of f of x. So we want to know what's happening to the graph as we move to the right. And it looks like we have one of those situations where we have a horizontal asymptote, but it's oscillating. At least I did my best to draw that. Certainly it's not perfect, but hopefully you understood my intention. And it looks like the value of that asymptote that we're looking at is -4. So that means that as x approaches infinity, f of x is approaching -4. So that limit is -4. Let's continue. Now we've got the limit as x approaches negative infinity. So we're looking at what's happening as we move to the left. And over here, it looks like we are asymptotically approaching 5. So that means that that limit is equal to 5. Again, these are hand-drawn. They're certainly not perfect, but I really hope you can see the intent in the graphs that I have drawn. All right, let's keep going. We've got the limit as x approaches 3 from the positive side, which means from the right. So we want to know what's happening as we approach 3 from the right. That's going to be this portion of the graph. And it looks like we've got a vertical asymptote there, and we are approaching negative infinity. So that limit is going to be negative infinity. Whereas if we look at the limit as x approaches 3 to the left, we can see we're going up towards positive infinity. So that one-sided limit is positive infinity. If we want to look at the limit, the two-sided limit as x approaches 3, unfortunately the left and right-handed limits are different. So that means that that limit does not exist. And then finally, we've got the limit as x approaches -5 of f of x. The function is not defined at -5. There's a hole in that function, but that's fine. If we look at what's happening to the left and to the right, the y values in both of those cases are approaching 2. And so that limit is equal to 2. And there we have it. When we have the graph of a function, usually we can do a decent job of reading the limits just from the graph. It's not always possible or easy, particularly if a limit is not an integer. If we've got some sort of a weird decimal, we're not going to be able to figure out what that exact decimal is by eyeballing it. But in this situation, obviously I'm trying to make a graph where you can eyeball things, so we can assume that this limit is 2 and not something like 1.8 or 2.1 or something like that. Of course, I'm trying to make things fairly simple to look at here.